Hello, I'm Dustin Carrion, and today I'm going to present to you a research about an analysis of factors that influence the performance of biometric systems based on electroencephalogram signals. This investigation was conducted in partnership with Rigoberto Fonseca and Israel Pineda. Over the past few years, electroencephalogram signals have attracted the attention of researchers because of their properties as a biometric trait. Nevertheless, despite of the advantages of these signals, it is still necessary to carry out a specific analysis to improve the future development of this kind of biometrics. In this sense, there is a need for a comparison between classifiers based on different criteria, because nowadays the current studies mostly compare the same classifier with different parameters. Moreover, the discrete wavelet transform is commonly used for preprocessing the signals, but even though this transform has been studied for years, the impact of the decomposition level over the performance of the system has not been studied yet. Finally, an analysis of the effect that the recording time has over the performance of the classifiers would provide a better understanding of how much time of electroencephalogram recording is needed to achieve a robust system. This study used two datasets. The first one is an open access dataset of electroencephalogram signals that contains information of 32 healthy participants, and each participant has 40 recordings, and each signal was recorded using 32 electroencephalogram channels with a duration of 60 seconds. On the other hand, we also use a private dataset recorded at the National Institute of Astrophysics, Optics, and Electronics. It contains information of 51 participants with 135 trials per subject. In this dataset, each trial was recorded with 14 electroencephalogram channels with a duration of 2.5 seconds. For preprocessing the data, we applied a discrete wavelet transform, and we used the WHS4 as model wavelet because of its ability for detecting changes in the electroencephalogram signals. We applied these four decomposition levels to collect information to further analyze this technique. After applying the discrete wavelet transform, the feature matrices were created using the relative wavelet energy, and they were scaled with min-max scaling for avoiding defects caused by different scales among the channels. We trained these 6 classification algorithms using a multi-class and closed-set classification approach. These classifiers were specifically selected because they have different classification criteria that allow us to compare between them. For finding the best hyperparameters for each classifier, we used a greedy search optimization, and for analyzing the performance of them, the average accuracy, macroaveraging sensitivity, and macroaveraging specificity were computed. These are the experimental results for the deep dataset. The left figure shows the sensitivity of the supervector machine, because it was the best classifier for this dataset, and the sensitivity was the lowest metric. In this figure, the impact of the recording time over the performance of the system can be seen because when it increases, the sensitivity increases too. However, we perform a Hoteling's t-squared test between the results of each time segment and the maximum time used in this study, which was 2.5 seconds. The p-values of this test are in the right table, and there we can see that with almost all the decomposition levels, the results of 1.75 seconds were not significantly different than the results of 2.5 seconds. And for this reason, the slope of the left figure decreases from this point. The results of DEEP were verified with the results of Biometric dataset, because as before, we can see the impact of the recording time over the performance of the best classifier, which in this case was Adams. And also the results present in table 2 indicate that 1.75 seconds of recording are enough to achieve the highest results. Finally, to conclude the presentation, I want to say that although the state-of-the-art recommends using 5 or 4 levels of the composition of discrete wavelet transform, fewer levels can be used and obtain significantly similar results. Additionally, the multivariate statistical analysis demonstrates that there is a point from which it does not matter if the available time increases, the performance of the system does not vary significantly. And using 1.75 seconds of electroencephalogram recording can be suggested for future studies because of the high results achieved with this time. Thanks for your attention. If you have any question, please feel free to contact me.